So we've got question 4 from chapter 14 review. So we're given an expression representing the depth of water at the end of a pier, T hours after low tide, and we're told a few things. So we're told at low tide, so when T equals 0, that D is equal to 2. And we're also told that when T equals 8, that D is equal to 6. And we're asked to show that R equals pi on 8 and P equals 4. So first I'm going to show you how to demonstrate that P equals 4. So if D equals 2 at time 0, let's just pop it into the expression we've been given. So 2 equals P minus 2 cos R, and we're told T is 0, okay? So times 0. Now, straight away looking at that, without even rearranging it, I know that cos of 0 is always going to be 1. So I can actually substitute in 1 here and say P minus 2 times 1. So now I get 2 equals P minus 2. And if I rearrange that, I can say therefore P will equal 4. Okay, so we've shown that P equals 4. So now let's show that R equals pi on 8. There's a couple of ways to do this. Let's go ahead and just do the same thing. We'll substitute those values into the expression. So 6 will equal 4 minus 2 cos, and then we've got R and at time 8. Okay, T equals 8. So I'm just going to say for now, let R8 equal theta, okay, and substitute in like I usually do. So then 6 equals 4 minus 2 cos of theta. And then what we can do is we can rearrange our expression so that we end up with 6 minus 4 over minus 2 equals cos theta. And I can solve for that, so I will end up with cos theta equals 2 over minus 2, which is minus 1. So at this point now, I know that the angle that I have the exact value of minus 1, so is going to be pi. So I'm really doing this. I'm saying cos negative 1, the inverse of negative 1, give me an angle of pi. So now I can substitute back in R8. So R8 equals pi, and therefore R equals pi on 8. So that's one way to do it, and we've done quite a few using that method. So the other way you can look at it is we know that the period is 16. We can work that out because we go from low tide to high tide takes 8 hours, and then in another 8 hours you're going to go back to low tide. So if your period is 16, and we know that our period equals 2 pi on n, but in this case we're looking for r, so 2 pi on r. And if our period is 16, then R is going to be 2 pi on 16, which is the same as pi on 8, okay? All right. The next part of the question, I'm just going to go up to here to do... Oh, no, sketch is next. Okay, let's go to the next slide. So if the first... asked to sketch this, so I've sketched it on Desmos actually, and you're told if the first low tide occurs at 4, when will the next low tide occur? So just remember T equals 0 is at 4 a.m, okay? So if the first low tide occurs at 4 a.m, when will the next low tide occur? So you can see on the graph that it's at 16, but we need to give a time. Okay, so it's 4 a.m. plus 16 hours. So the answer is going to be 8 p.m. All right, so the next question, part D, asks, at what time will the depth be equal to 4 metres? And on Desmos, I've just put in a line to show that depth of 4 metres. So in one cycle, we can see the range of times that, well, actually, the 2 times that the depth will be 4 metres, okay? So we can actually look at that and read it off the graph, but if you want to do it mathematically without the sketch, we just need to then go in again and substitute in for D and then find T. So let's put in, so 4 equals 4 minus 2 cos pi on 8 t. 4 minus 4 divided by minus 2 equals cos pi on 8 t. So that's going to be 0. So let's just say again, cos theta equals 0. And then think to yourself, well, when does cos theta equal 0? Okay. At what angles? So it's going to be at pi on 2 and 3 pi on 2 is when cos returns a value of 0. So now we can just sub back in pi over 8t equal pi on 2 and 3 pi on 2. And then if I now want to just get t, I'll have t equals pi on 2 times 8 on pi and 3 pi on 2 times 8 on pi. Okay, so we're going to have some pi's cancelling here and here, and we're going to get 8 divided by 2 is 4, and we're going to get 24 divided by 2 is 12. All right. Now, they represent hours after the first low tide, so we actually have to make sure we put in the times. So 4 a.m. plus 4 hours is going to give me 8 a.m. and 4 a.m. plus 12 hours is going to give me 4 p.m. This next part of the question tells you that the poles that support the pier stand 7.5 metres above the seabed, and you're asked how much of a particular pole is exposed at high tide. So we can sort of look at the graph there, and we know that the maximum depth is 6 metres. So for that first part, you just need to subtract 6 metres from 7.5 metres. Okay, so 1.5 metres is exposed. The next bit you're asked how much at 2 p.m. Again, I guess you could look at the graph. First, you need to figure out, well, what's 2 p.m.? So 2 p.m. on this scale is going to be t equals 10. Okay. And we can just actually substitute that into the original expression. Make sure that your calculator is in radians. Okay, so first we find the depth. So this expression I've just substituted in t equals 10 for 2 p.m. and then we'll get a depth, and that gives us 5.414 metres, but we need to obviously take that away from 7.5, okay, to see how much of the pole is exposed. So 7.5 minus 5.414, and you'll get 2.086 metres. Part F, we're told that a particular muscle is attached 4 metres from the top of the pole. So we have to find the time that it's covered by water. I've actually just put this sketch here from Desmos. So this line, you can't see it clearly, but it's at 3.5 metres. If the pole's 7.5 metres and the muscle is attached 4 metres from the top, then it's going to be at a depth of 3.5 metres. And you're asked how long will it be covered by water during the time from one low tide to the next. So the bit that it's asking you to work out is all in here, like this time here, where it's covered by water. Okay, a couple of ways again to do this. So if I can find out this time here, and I know that this is symmetrical, I'm going to reach this point again over here, then I can, that's one way I can work it out. I can put this time into my equation and figure out periodically what this other value is going to be. So let's just go ahead and start it. So I'm going to have now 3.5 is my depth, okay, and I'm looking for my time, equals 4 minus 2 cos pi on 8t. Okay, and once I've rearranged all that, what I end up with is a quarter equals cos pi on 8t. And again, I'm going to let theta equal pi on 8t. Now, when you don't know this exact value, a quarter, that's when you're going to use your calculator. So you do the inverse of a quarter, and it's going to return a value in radians. Okay, so the value you get in radians is going to be 1.318, and it's a positive value. So if it's a positive value, and we're talking about cos, we need to think of, you know, the next time that you would have that positive value. All right, so think about my unit circle. If I've got 1.318 radians here, and I've got a value of cos, I'm also going to have the same value of cos down here. So the way that I work it out, the next value would be, I'll just start here, theta equals 1.318. Or it can also be 2 pi minus 1.318. So that is also going to return me the equivalent value of cos, where cos is positive here. So I end up with 1.318 and 4.96. But now I have to substitute back in for theta. So pi on 8 t equals 1.318 and 4.96. And then if I solve for that, I end up with 3.356 and 12.6. Now, they represent those 2 points that I've marked on the graph, but we want to know for how long. So we need to actually subtract one from the other. So 12.6 minus 3.356, and that's going to give me 9.23, I think. I want to double check that. All right, I've cleaned up these numbers a little bit, so it's a little bit more accurate. So 12.63 minus 3.356, and then we get 9.27, but just remember that 0.27, you can convert it to minutes, so it'll be 0.27 times 60, which is 16.2. I think the answer has 9 hours and 17 minutes. So I got 16, but anyway, I've probably got a rounding error. So that's the answer.